Alright, in this video we want to continue our discussion on vectors, but in this one we're going to look at adding more than two vectors together. We also want to talk about vectors in different quadrants other than the first, negative vectors, and also subtracting vectors, as well as another notation that you can use to write vectors. So first of all, let's look at adding more vectors than two. Let's say you have a treasure map and it tells you to go 5 paces to the north. It tells you to go 3 paces to the east. It tells you to go 4 paces due southeast. So it's going to be halfway in between south and east. And then that's going to lead us to our treasure. So first of all, we have this vector. We're going to have this vector going north 5 paces. We're going to have this vector going east for 3 paces, and we're going to have this vector going southeast for 4 paces. Notice this third vector is oriented down and to the right. Just a quick review here. If we have a vector pointing up and to the right, that vector is going to have a positive x and a positive y component. If it's pointing down and to the right, it's going to have a positive x component but a negative y component. If it's pointing up and to the left, it's going to have a positive y component but a negative x component. If it's pointing down and to the left, in this case it will have a negative x component and a negative y component. So we can kind of pretend, since we're adding these vectors from where the previous one started, we can kind of pretend there's this mini coordinate plane right here. And from that mini coordinate plane, this 45-degree angle is made from the horizontal. But in this case, notice, since we have a case like this blue vector down here, we're going to have a positive x component for that vector and a negative y component. So let's do what we did before, add up all of our x's and all of our y's. So let's look at this first vector, 5 paces to the north. There's no paces in the x direction, they're all in the positive y direction, so we'll put 5 under our y. Let's look at this second vector, 3 paces to the east. Again, there's no movement in the y direction, so we're not going to add anything to our y total. But in the x direction, there is movement, 3 in the positive direction. Finally, we have this third component that's going to lead us to our final vector where the treasure is, 4 paces southeast. So in this case, we're going to have a vector 4 oriented at an angle of 45 degrees from the y-axis or 45 degrees from the x-axis, depending on which way you look at it. If you go all the way around, that's going to be 315 degrees if you start at your positive x-axis. It's going to come all the way around to 315 degrees. So in this case, we can find our x component of that vector, which is going to be the 4 times the cosine of 315, which is going to give me 2.82. And also in the y direction, if I take the sine of 315, be careful about where you're knowing which quadrant your vector is in, because in this case it's going to give us a negative 2.82. We're going down from where that 5 took us, so therefore it's going to be subtracted from that 5. So if I add up all my x coordinates, I should get 5.82. If I add up all my y components, I get 2.2 in the y direction. And again, to get that final resultant vector, we're going to take 5.82 squared plus 2.2 squared is equal to my resultant squared. And I get my resultant is equal to 6.22. Again, to find the angle, I can take my total x right here and my total y and use tangent of theta is equal to 2.2 over 5.82. And if I inverse tangent that fraction, I should get 20.7 degrees. Remember, this 20.7 is being measured from this horizontal right here. So it's 20.7 degrees. The resultant vector is 6.22 paces. So now we looked at adding vectors. Now we want to look at subtracting vectors, which is essentially the same thing. Only we're going to reverse one of the vectors. So let's say I have a vector A pointed this way, and I have a vector B looking something like this. If I wanted to know what is A minus B, I'm going to flip this B vector 180 degrees in the opposite direction. So it's going to be facing the opposite way. So this is negative B. And then I'm just going to add A plus negative B, just the way I would have added A plus positive B, only negative B is flipped 180 degrees in the opposite direction. Another thing about vectors is our notation of them. We've been saying, usually we'll say some number like 5.26 meters per second squared, we'll say, at an angle of 35 degrees when we find that angle. This is an example vector. It's perfectly fine to notate it that way, but I just want to show you another way you might see vectors written. And they're usually called like IJK notation or unit vectors. What these are is they represent in each plane or in each direction. This I represents one unit in the x direction. So one unit in the x direction is I hat. That's what that little caret is called, is hat. One unit in the y direction is called j hat. And you can't see this, but pointing in and out of the page at you would be my k hat vector in the z direction. We won't talk a lot about 3D in this class, but just pretend this is pointing straight out of the screen at you, that k hat unit vector. We're just going to worry about this 5.26 oriented at 35 degrees. It's going to look something like this. So we'd have 5.26 oriented at 35 degrees from the horizontal. Let's break that down into its components. So the x component would be 5.26 cosine 35. The y component would be 5.26 sine 35, giving me 3.02 and 4.31 for my x. So one way we can write this is we could say that this vector is also the same as 4.31 I hat plus 3.02 j hat. This vector is how we'll usually write it, but I just want to point out that it's the same as this. It's just two different ways to represent the same vector. This method can be very useful for that example we did earlier when you're adding a bunch of different vectors. You would simply just add your I hats and add your j hats, and possibly if you had k hats, add those, and then you would end up with your final answer. So let's just look at one final example of adding two types of vectors. We could have something like 2.76 meters at 10 degrees. And what if I said 3.88 meters at 35 degrees from the vertical or from the y-axis? Sometimes you might hear something like this. This time we're measuring, so we have our 2.76 meters at 10 degrees. If we measure 35 degrees from the vertical, it might be something like this, and then 3.88 meters. If it's 35 from the vertical, that simply means it's 65 degrees from the horizontal, because I just took 90 minus 35 to get that angle from the horizontal. Now I can continue my operations as usual. So let's break those down into their x and y components. The first one, 2.76, is x component is going to be 2.76 cosine of 10. The y component will be 2.76 sine of 10. For the other vector, you're going to get 3.88 cosine of 65 and 3.88 sine of 65. You could have also done sine of 35 for the x and cosine of 35 for the y. There's several ways to go about doing these problems. But you're going to end up with 2.71 and 1.64 for your y components respectively. You're going to end up with 0.479 and 3.52 for your y components. Let's add those together. We get 4.35, and we can write I hat, and we get 4.0, and we can write j hat. The units for those will usually come before the hat notation, and we would end up with a final answer something like this. Sorry, it's a little sloppy there, but it'd be 4.35 I hat plus 4 j hat.